Now in the section 3 we have some reasoning type of questions. So the 11th question here is, consider the system of equations ax plus by equal to 0, cx plus dy equal to 0, where a, b, c, d belongs to the set containing 0 and 1. And now the statement 1 here is, the probability that the system of equations has a unique solution is 3 by 8, and the statement 2 here is, the probability that the system of equations has a solution is 1. So here we know that the system of equations here is ax plus by equal to 0 and cx plus dy equal to 0. Now here we know that for unique solution the determinant value should not be equal to 0. That is, for unique solution this determinant a, b and cd should not be equal to 0. This means what? Here this means this ad minus bc should not be equal to 0, where the values a, b, c and d belongs to the set containing the elements 0 and 1. And now listen, here the total number of cases will be equal to what? It will be equal to 16. That is, we can arrange these 4 values in 16 ways. And now here what are the favorable cases? So here the number of favorable cases will be equal to 6, because we need that this AD minus BC is not equal to 0. So here to satisfy this, either this AD equal to 0 and BC equal to 1, or this AD equal to 1 and this BC equal to 0. So therefore the number of favorable cases here is this 6. So now what will be the probability? So therefore the probability that the system has unique solution is, so this will be equal to what? This will be equal to the number of favorable cases 6 divided by the total number of cases 16. Now if we cancel these two values, we will get 3 by 8. So therefore the probability that the system has unique solution is 3 by 8. So this means what? This means the statement 1 is true. And now what we are going to do is, we are going to find out the probability that the system has a solution. So here the probability that the system has a solution is, so here this will be equal to what? This will be equal to the total number of cases 16 divided by 16, which is equal to what? 1. So hence we get the probability that the system has a unique solution is equal to 1. So therefore we get the statement 2 is also true. So statement 1 is true as well as the statement 2 is true. So hence out of these 4 options, option B, statement 1 is true and statement 2 is true, but the statement 2 is not a correct explanation for statement 1 is the required answer. And now we are going to see the 12th question. Here the question is, consider the system of equations x minus 2y plus 3 is equal to minus 1, minus x plus y minus 2 is equal to k, and x minus 3y plus 4 is equal to 1. And the statement 1 here is, the system of equations has no solution for k not equal to 3. And the statement 2 here is, the determinant, that is this determinant is not equal to 0 for k not equal to 3. So now listen, we are going to find the determinant value first. So here we know that the given system of equations is this one. So now by using this we can easily find the determinant first. So here the coefficients of x are 1, minus 1 and 1. Coefficients of y are minus 2, plus 1 and minus 3, and the coefficients of z are plus 3, minus 2 and plus 4. So now we are going to find out this determinant. So here this determinant will be equal to what? Modulus of this minus 1, modulus of this plus 1, minus 2, 3, and minus 1 plus 1 minus 2.